Hey everybody, this is number 8 from the classwork on Tuesday. So you're driving in a 2,500 kilogram car at a constant speed of 14 meters per second along a wet but straight road. As you approach an intersection, the light turns red, so you slam on the brakes. The car's wheels lock and the tires begin skidding. The car slides to a halt in 25 meters. What is the coefficient of friction? Kinetic friction between your tires and the wet road. So this one is a little more complex, and it does bring in some things that we've done in the past. So I wanted to go over this just to make sure makes some sense. All right, so here we go. First step, free body diagram. So let's get this going here. We have the object and we have all the forces acting. So we have the weight force, we have the normal force. Okay, these are equal and opposite, they cancel each other out. The object is not accelerating in that vertical direction. Now when you step on the brakes, the only force acting on the car is the friction. There is no more engine force, there's nothing. So if, and why don't we do this, we probably should have done this before, we make to the right and up positive, then the friction will be in the negative direction, and that's kinetic. There we go. So these are our three forces. They are the only forces acting on the car as it is coming to a stop. All right, next, a good idea, we'll write down some known values or some givens. So here we go. What do we have? Well, we're given the mass of the car, 2,500 kilograms. We're also given the velocity of the car when it starts to slow down, and that is 14 meters per second. And we're given the distance, delta x, and that is 25 meters. Alright, so we have a couple of vectors here. I'll put those up. Alright, so those are the givens. Now, the next thing I want you to do is to write the sum of the force equations. Alright, so we're going to add up, we're going to go sigma, sum of the forces in the x direction, and we're going to do the sum of the forces in the y direction. Alright, sum of the forces in the x. What we have the force of friction. That is it. So there is our force of friction. Now, is it accelerating the x direction? Yes, it is. So therefore, the force of friction, the net force, equals m times a. And there we go. All right, now, in the y direction, vertically, is it accelerating? Is it speeding up or slowing down? No, it is not. So therefore, the sum of those forces and minus the weight equals 0. So there's our net force equations. And then we got to say, all right, well, let's start looking at things we can solve for. So let's see what we're going to do. We'll take the bottom one for weight. So we know we can solve for the weight because weight is equal to mass times the acceleration of gravity. 2,500 times 9.8. So you can do that math, but you end up with 24,500 newtons for the weight of the car. All right, very good. Now, from that point, we got to start figuring out the force of friction. Okay, so force of friction, we're going to write out this equation. Fk is equal to m times a, right? Because the net force in the x direction is equal to force friction, and it equals the mass of the car times the acceleration of the car. All right. Okay, Sal. Now, we have the mass, but we don't have the acceleration, and we don't have the force of kinetic friction. So we have two unknowns we can't solve. But let's look at what we do have. If you look back, we have the velocity of the car before it comes to a stop, and we have how far it went. So let's go over here, and we got ourselves a kinematics problem. Yes, I told you, this stuff doesn't go away. So here we go, initial velocity before it started braking, 14 meters per second. Velocity at the end, well, it comes to a stop, so 0 meters per second. Delta x, we know, is 25 meters per second. And the acceleration, that's what we're going to find out, because that's going to help us find the force of kinetic friction. So let's do our equation. We say Vf squared equals Vi squared plus 2a delta x. All right, now we rearrange that, and we end up with Vf squared minus Vi squared divided by 2 delta x. All right, so what we end up with, I'm going to move this up a little bit, we end up with the acceleration equals negative 3.92 meters per second squared. Okay, not bad. So here we go. Now we're going to go back up to where we were. Now we can find a value for this force of kinetic friction. So we plug this in, force of kinetic friction equals the mass, 2,500 kilograms, times the acceleration, negative 3.92 meters per second, and you end up with a value of negative 9,800 newtons. All right. Very good. That's important. So now we have 9,800 newtons. Now, what do we do with that? Well, now we're asked to find the coefficient of kinetic friction. Well, we know that the kinetic friction, in addition to equaling mass times acceleration in this case, is also equal to the coefficient of kinetic friction times the normal force. So now we can rearrange and solve for mu k. Mu k equals Fk divided by the normal force. All right, and we end up with Fk, we found 9,800 divided by the normal force, which if we look back was equal to 24,500. And when we write that out, we end up with a value for mu k of 0.4. So that is a unitless quantity. It is kind of a multiplying factor, if you will. And there we go. That is our final answer. All right. Hope that was helpful, and we'll catch you on the next one.